From section 7.2, we're going to do number 27, where we need to solve that triangle using the law of cosines if possible. So I'm going to start by drawing a random triangle, 3 straight sides. I don't want to make it look like a right triangle. Try to make it a little different. Okay. There we go. I don't know what it looks like, so I'm not drawing it to scale. So I'm just drawing a random triangle. And we'll start with the biggest side. So side A is 15 radical 3. So that's across from angle A. Side C is 10 radical 3. So that's across from angle C. And side B is 6 radical 3. So that's across from angle B.
You will be.
Okay, so this is the side triangle. So I'm going to use this section of my notes to guide me of what to do. So the first thing we do is the law of cosines to find the largest angle. Notice the largest angle. So when we have 3 sides or 3 angles to find, start with the largest one and then you avoid that ambiguous case. So the first step would be, actually I'm going to move this up and out of our way. Since we don't need all those notes, I'll just keep that. Okay, so law of cosines. And since I'm looking for the largest angle, that's going to be across from the largest side. So that's angle A. I'm looking for angle A. And that means I have to use the cosine equation that starts with side A. So that side A equals B squared plus C squared minus 2 times BC. So it's A squared, one side squared equals the sum of the other 2 sides squared minus 2 times the other 2 sides times cosine of that angle. So remember, those match up. So I can go about this in 2 different ways. I can either plug in the numbers now and then solve for my one unknown, which will be this A, or I can rearrange the equation in this form to solve for A and then put in the numbers. I'm going to do that second option because once I plug in the numbers, the equation gets busier. So I'm going to just solve for A in the equation as it is right now and then plug in the numbers at the end. So to do that, the first thing I need to do, I need to get that term with A. This is the term that has the A. I need to get that by itself, which means I need to subtract this and this. So I get minus B squared and minus C squared from both sides. So I get A squared minus B squared minus C squared equals negative 2 BC cosine of A. And then to get the cosine of A by itself, I'm going to divide this whole thing by negative 2 BC. So I get that cosine of A equals A squared minus B squared minus C squared all over negative 2 BC. Now I'm going to plug in those numbers. So cosine of A, that's my unknown. I'm looking for A. And I know all the numbers on the right, I just have to plug them in. So A is 15 radical 3 squared. B is 6 radical 3 squared. And C is 10 radical 3 squared. All over 2 times B times C. All right, so that gives me, let's see, 15 squared is 225 times 3 squared, radical 3 squared is just 3. 6 squared is 36, and radical 3 squared is 3. And 10 squared is 100, and radical 3 squared is 3. All over so I have, let's see here, 2 times 6 is 12, times 10, doing the denominator, times 10, that gives me 120. And then the radical 3's multiplied together gives me a 3. So radical 3 times radical 3 gives me 3. And now I'm noticing that I have a factor of 3 in every single term. So there's a subtraction sign in the numerator, but as long as I take the 3 out of every term, that's allowed. So now I have, let's see, 225 minus 36 minus 100 all over 120, which is 89 minus 120, 125 minus 36. Yeah, 89 over 120. So I have, oh, and a negative, sorry. That was a negative. I lost a negative there. Okay. So then I have cosine of A. That negative came from the denominator. So I end up with a negative in front. So cosine of A equals a negative 89 over 120. So to find A, I do cosine inverse of that. And I'll plug that into my calculator. And I get let's round that to 137.9 degrees. So that gives me angle A. So going back to my solution, I need to make a little table here. And I got 137.9 degrees for angle A. Okay, so that's step 1 from that. And then the next thing to do is to use a law of sines to find another angle. And at this point, it doesn't matter. We can find angle B or angle C. So this is step 1 here. Going on to step 2. Using the law of sines. So I'm definitely going to use that information because I need an angle for my law of sines. So I'll do sine of A is to A as sine of, again, it doesn't matter if I use B or C at this point. So I have sine of A is sine of 137.9. And side A is 15 radical 3. Sine of B is, I guess, what we're looking for. And side B, 6 radical 3. Okay, so cross multiply to get that equals that. And to get sine of B by itself, divide both sides by 15 radical 3. So I get sine of B equals, get my calculator out for that one. 6 times radical 3 times sine of 137.9 divided by the product of 15 times radical 3. Make sure you use your grouping symbol on the denominator, typing that into a calculator to show that that multiplication is going to happen after the division. Otherwise, PEMDAS will go left to right, so we'll do the division first. So you got to use your parenthesis to show that the denominator, to show that grouping symbol of the fraction bar. And for that, I get, that's the sign, 0.268. So to get B, I take the sine inverse of that. So that's, oh, you know what, I'm just going to leave that in the calculator and put my sine inverse right in front. Nope, that's sine. Sine inverse. And I get, oh, B is 15.6 degrees, rounding to the nearest tenth. So now I can stick a 15.6 right here. And to get that third angle, I will use the triangle sum theorem. So that is step 3 right here. 180 degrees minus 137.9 degrees minus 15.6 degrees, which gives me 26.5 degrees. And that is a final answer.